overall coarsening upward trend, which here is represented by a set of coarsening upward trends which are getting successively sandier and more proximal upwards. I would interpret these then as para sequences, and because they're getting cleaner, coarser and more proximal upwards, I would put them in a progradational mode. So that would be a progradational para sequence set sitting in there, which I'm going to put in the shelf margin prograding wedge in the low stand. And then the surface on the top here, admittedly our database is limited here, but we see a first little para sequence which is 50% sand, which is about 20% sand, wave action is increasing upwards, marine influence is increasing upwards. The third one has storm signatures in it, really nice gutter cast, so that's even more marine upwards. So I'm going to interpret that as a backwards retrogradational para sequence set. Back and the deltas are being pushed back away from us. These are the times of deltas that are being progressively pushed back to the west. We don't see what happens next, because the next thing that happens is we've got this big thundering erosion surface coming through. The thickness of the sand, at least 40 metres of erosion. And I'm going to interpret that as an erosive sequence boundary produced by downcutting of the fluvial system. Internally, the individual channels are 6 to 7 metres, so that container is a lot bigger than a single channel. So that's one signature of it being potentially a valley. The second one, of course, is you've got a huge downward basinward shift of facies there. Shelfal material, good shelfal material with gutting mass, and then fluvial sands right on top. And that's stuffed full of fluvial sands. The other nice signature is that the erosion surfaces are very closely spaced in the bottom, so accommodation space growing in that valley during the rising limb is slow initially, so as the channels move around they're amalgamating and cutting. As the accommodation space, the bit of accommodation space grows through time, the rate increases as the rising limb comes up, you start seeing the erosion surfaces stepping and spacing away from each other. So greater and greater preservation of big channels. And then you've got a major marine surface over the top, so that's when the rise in sea level hits the margins of the valley. As soon as it hits the margins of the valley, we transgress. We get shelfal marine conditions right on top of the fluvial sands. There's a lot of sediment supply being pumped into this basin, I'll come back to that in a moment. So during the transgression we can still prograde a significant deltaic complex. Our maximum flooding surface, and the whole deltaic system is way back at the west now. And then we see on top of that some pro-deltaic shale which we put in the high stand, and then we get another one of these downward shifts in the Kilkee, and the next low stand wedge comes in. So one cycle of them appears to convert in this interpretation into two sequences. So what should we see? We should see another maximum flooding surface, and in the Kilkee that's what we see. Right here should be another maximum flooding surface, another little bit of high stand which is then cut down by the sandstone. So this interpretation is sending out a nominal signature seeing this cycle a little bit more distal than the next one, which we're seeing more proximal. So let's show you how big these valleys really are.